just an introduction first on chapter 3. So, sorry if you seems that I'm rushing the courses sebab kamu pun tahu kan 14 minggu, and usually I would try to finish as much as bukanlah macam nak terlalu banyak, but at least throughout the end of the semester when you have already a lot of assignment, a lot of things, at least you have the time. That's why I try to do it. Taklah cepat pun. Actually, I didn't do it that rush actually. Just that I fully utilize the time. So tomorrow again, besok kita ada kelas ganti. We have a replacement class tomorrow at 9 o'clock, but the replacement will be tutorial 9 to 11, almost pun sampai 11.30 lah. Right? Okay, so chapter 3. Okay, so chapter 2, if you ask me, it's not that difficult, I think, but chapter 3 has become a little bit more complex. Chapter 2, of course, as I said, mestilah kena faham chapter 2. Okay, sebab chapter 2, I already explain you about the equation. Tapi yang paling penting is actually chapter 3, chapter 4, chapter 5, chapter 6. Meaning, kalau kamu tak faham chapter 3, it's going to be very, very difficult in chapter 4. And it's going to be very, very difficult in chapter 4 lah. Chapter 4 is actually the hardest one if you don't understand chapter 3. Chapter 5 is okay. Chapter 6 pun not that difficult, but actually the integral part is actually chapter 3 and chapter 4. Okay, so first of all, continuation kepada apa yang kamu kena belajar dalam chapter 3. Okay, now kalau kamu perasan in chapter 2, you already started calculating the volume of the reactor. Kamu cari volume reactor PFR, you find the reactor volume of CSTR. But if you realize you are calculating the volume using the table or the plot of which you know your minus RA daripada X tu. Maksudnya kata X saya 0.1, berapa minus RA saya? X saya 0.2, berapa minus RA saya? Okay, so in that sense, kamu dah diberi minus RA itu, kamu cari volume. Okay, means you assume katakan dalam senario tu, someone has already done the work to find the minus RA, kamu cari je volume. Okay, but however, if let's say in a real application, as if your reaction is a common one, of course, the information is readily available. Tapi even that pun, someone has to run that in the lab. Okay, now you assume you're running a new type of reaction, or let's say you modify some parameters in the reaction, data tu dah tak valid, kamu nak kena cari balik minus RA dia. So now you are learning in chapter 3, sebenarnya how do we find that minus RA? So finding that minus RA is actually very, very difficult. Sebab tu design reactor jadi susah sebab sebenarnya that minus RA is not easy to find. So sebenarnya dah chapter 2, kamu dah diberi nilai tu, kamu kira je. Tapi sekarang chapter 3, kamu belajar how do we actually find the minus RA. So minus RA ni kamu kena ingat, it really depends on the reaction. And it also depends on conversion. Okay, so how do we do that? Okay, first of all, okay, this is what we call as finding minus RA. Kan? Tadi kita katakan check minus RA. Okay, so finding minus RA is actually we do based on what we call as rate law. Okay, so rate ni pun ada law dia. So the rate law minus RA, dia saya cakap pasal rate law ke apa ke, sebenarnya kita nak cari minus RA. Sebab tanpa minus RA, tak boleh cari volume. So the rate law links the reaction rate minus RA with reactant concentration. Dia sentiasa reactant concentration. Kalau ada satu reactant, A. Kalau ada dua reactant, let's say A and B. Okay, it can depends on A, it can depends on B, it can depends on A and B. Kalau dua reactant. Okay, ingat. Okay. Kalau satu reactant, it depends on only one reactant. Let's say A, hanya depends on concentration A. If I have two reactant, A dan B, so the rate law can depend on either A or B or both. Okay, tu kamu kena faham betul-betul. Kalau ada dua reactant, rate law dia boleh berdasarkan concentration A atau concentration B atau concentration A dan B. Okay, right, next. Dan also reaction rate constant K. So now you learn another one more new parameter, we call it K, reaction rate constant. Okay, so minus RA, reaction rate. K, reaction rate constant. Kamu kena bezakan kedua-dua ni. Minus RA, reaction rate. K adalah reaction rate constant. Okay. So how do we correlate all these? Hence, we use power law model. So power law model says minus RA, yang sebelum ni kamu terus dapat nombor, tapi sekarang kamu dah kena kira sendiri. Minus RA equals to K. K tu sentiasa ada di hadapan. You cannot escape. The K must be there. In bracket, concentration of your reactant. Contohnya, in this case, I have two reactant. So, concentration A, concentration B. CA, CB. C subscript A, concentration of A. C subscript B, concentration of B. Okay, so kenapa concentration ni tak ada not? Kan ingat, concentration kan bergantung, minus RA kan bergantung kepada conversion. So, kalau conversion berubah, concentration of course changes also. So, dia bila kamu kira that minus RA at that conversion, you will use that concentration. Dia tak ada not. Dia mesti concentration at that conversion. That's why CA, CB. Done. Then, you realize there's a power there. There's alpha and beta. Okay, so lagi benda baru kamu kena belajar. Alpha and beta is the power type refers to reaction order. So after this kamu akan sentiasa dengar reaction rate constant. You always hear minus RA, and third you will always hear reaction order. Okay, dalam bahasa Melayu, K is pemala kadar tindak balas, reaction rate constant. Alpha beta reaction order. In Malay, we call it tertib tindak balas, reaction order. Okay, so apa tu reaction order? Okay, right. So reaction order ni, dia adalah number. Okay, but it can be zero order, it can be first order, it can be second order, it can be third order, it can be fourth order, so on and so forth. However, kamu kena ingat, order dia berlainan, design equation dia jadi berlainan. Okay, so but typically, usually reaction order dia adalah zero order, first order, second order. So in this class or for this course, I will teach you typical reaction that only zero order, first order and second order. Okay, saya tak ajar untuk third order, fourth order and so on. Sebab kalau kamu belajar order yang berlainan, design equation dia jadi lagi banyak. Sekarang pun dah 40-50 equation I told you. If we go more than that, it become a lot more design equation. Okay, so apa tu order? Order of reaction with respect to the reactant. Okay, kamu kena ingat, order reaction ni specific kepada that compound, meaning that alpha is refers to the order for A. Beta refers to the order of B, compound B. Alpha refers to order of compound A, beta refers to the order of compound B. Okay, and it's defined as the power to which a reactant concentration term in the rate equation is raised. Okay, so apakah maksud ayat ni? Alright, so saya terang dalam nak terang reaction order ni cara yang senang. Okay, kamu kena faham macam ni. I use example satu reactant dululah. Okay, katakan reactant dia, you only have one reactant A. Okay, so katakan rate law dia, let's say the rate law is written as minus RA equals to K CA alpha tu first order. So alpha tu kuasa 1. Kuasa 1 biasanya kita tak tulis pun tak apa kan, sebab CA kuasa 1 masih CA. Contohnya 4 kuasa 1 masih 4. So you can still write as KCA. Tak payah tulis KCA kuasa 1. It's the same. So meaning kalau you write it as minus RA equals to KCA is first order with respect to A. Apa maksud dia? Maksudnya dalam reaction tu, I have one reactant, right? So for the reaction to occur, that one molecule of A tu akan decompose. Ataupun dalam tindak balas tu hanya melibatkan satu sahaja molekul A itu. Okay, ataupun satu sahaja concentration A itu. The easiest way to explain. Okay. Now, katakan maknanya dia akan decompose lah, satu molekul ni akan decompose ataupun dalam arti kata lain dia akan pecah. Satu molekul itu pecah. So, order dia first order. Okay, katakan dia kata is equals to KCA power of 2, kuasa 2. Meaning, reaction order dia adalah second order. What does it mean? Meaning, during the reaction, in the reaction involved, two molecules of A, most likely dia combine untuk membentuk produk. Tadi yang first order, satu molekul itu pecah membentuk produk. Kalau second order, two these molecules will likely combine. Arti kata lain combine lah, mechanism dia, reaction dia kita tak tahu. Dia can jadi, it can be oxidation, it can be a lot of type of reaction. Tapi konsep dia adalah combination of two of these molecule to form product. Okay. Sebab tu dia commonly either first order atau second order. Kalau third order, which is very unlikely, sebab third order tu melibatkan 3 molekul A yang combine, which is very unlikely lah. Normally memang either combination or decomposition. Okay, tu kalau satu reactant. If two reactant, okay, case two reactant ni yang kadang-kadang student akan jadi a bit confused. Okay, katakanlah combination reaction tu ada 2 reactant. Okay, reactant A, reactant B, react. Okay, so tapi kamu tengok reaction order dia punya rate law. Rate law dia boleh menjadi, okay, katakan minus RA, dia ada 3 possibility. Actually lebih banyak, tapi the most likely possibility kalau kita ada 2 reactant, 3 possibility. 1, rate law dia minus RA equals to KCA CB. Mean first order with respect to A, first order with respect to B. First possibility. Kalau possibility itu means 1A combine with 1B. Dia react lah kan. React, produce product. Which is what normally student akan faham. Yalah, biasa reaction kan, saya ada A dengan B, saya gabung, dapatlah produk. So you get the rate law, minus RA equals to KCA CB. Okay. However, it's also possible rate law dia jadi minus RA equals to KCA. First order with respect to A. Ataupun dia boleh juga menjadi minus RA equals to KCB. First order with respect to B. So, kamu perasan, kenapa kalau kes pertama tak ada CB, dia jadi minus RA KCA, itu saja. Means, maksudnya first order with respect to A, zero order with respect to B. Sebab tu CB tu dah tak ada. Ataupun senario ketiga, minus RA equals to KCB. CA tu tak ada. Means first order with respect to B, zero order with respect to A. Dah tak ada CA dalam rate law tu. So this part, often student will get confused. Kenapa? Tapi saya ada 2 reactant. Kenapa rate law dia tak ada melibatkan satu lagi molekul tu? Okay. This is to explain the complexity of reaction. Biasa bila kamu ada satu tindak balas, dia jarang berlaku menggunakan satu jalan sahaja tau. Kamu bayangkan, contoh senang, kamu nak pergi daripada MySet, you want to go to MUA. Okay. So, kalau cara yang senang kamu imagine, kamu naik satu kereta daripada MySet terus sampai MUA. Kalau kamu menggunakan cara tu, KCACB. Tetapi, sometimes kamu mungkin menggunakan cara yang berlainan. Mungkin daripada MySet ke Melaka Central, kamu naik dulu kereta. From Melaka Central to MUA tu, kamu naik bas. Kamu masih sampai MUA, tapi kamu menggunakan jalan yang berlainan. Kamu menggunakan 2 jalan yang berlainan ataupun 2 cara yang berlainan. Reaction pun macam tu. You have different mechanism taking place at one time in the reaction. Dia bukan satu je cara, banyak mechanism. Okay. So rate law ni, technically kamu boleh kira berdasarkan mechanism yang berlainan kan. Maksudnya, katakan untuk tindak balas A dengan B ni untuk menghasilkan produk, mungkin mekanisme dia A tu kena pecah dulu baru bertindak balas dengan B. Ataupun possible B tu pula yang kena pecah dulu baru bertindak balas dengan E. Ataupun possible juga A dan B kena combine dulu baru bertindak balas dengan B. Ataupun B tu kena 2B kena combine dulu baru bertindak balas dengan E. So rate law ni akan berdasarkan kan kamu faham, kalau ada banyak mekanism, technically rate law boleh kira berdasarkan banyak mekanism kan. So rate law ni dia akan kira berdasarkan only one significant mechanism, ataupun kita kata rate law ni adalah yang penentu tindak balas, or penentu the extent of the reaction, or in the simplest way, the most significant mechanism tu yang kita kira rate law dia untuk penyeraan design kita. Sebab kita design reactor, takkan kita nak ambil kira rate law untuk semua mechanism, tak boleh. Kita pilih the most significant reaction, itulah rate law yang kita kira. So dalam kes A dan B ni, kan saya kata, kenapa rate law dia can be KCA? Maksudnya, tindak balas yang mechanism yang significant adalah sebenarnya A tu kena pecah dulu, baru dia boleh bertindak balas dengan B. So rate law tu based on the decomposition of A first, itu yang kita kira rate law dia. Ataupun as I told you, KCB. Means I calculate the rate law based on the decomposition of B. Okay, itu yang saya kira rate law dia. Walaupun tindak balas dia sebenarnya melibatkan B kena pecah, B decompose first, then B combine dengan A, so on and so forth. Sebab tu in the case, you can see sometimes we have minus RA equals to KCA power of 2CB. What does it mean? Second order with respect to A, first order with respect to B. Means dalam tindak balas dia, mekanisme dia adalah 2A have combine bertindak balas dengan B. So you have to understand, sometimes also can be rate law dia minus RA KCA square. Ada dua reaktan, tapi kamu tengok rate law dia, kenapa KCA square? Means tindak balas mekanisme dia yang paling significant, A tu kena combine dulu, baru dia boleh bertindak balas dengan B. So rate law dia kita kira berdasarkan the combination of BA first. So rate law, as I told you, dia ada banyak mekanisme. Kita pilih mekanisme yang paling significant. Rate law tu yang kita akan guna untuk design reactor. Okay, so I hope you understand this, because in my PhD study, I do this. I study reaction. I study one particular reaction, and I study all the possible mechanism of that one reaction, and I determine the rate law. And from that rate law, I can actually predict, I do modeling system and so on, and I can predict what reaction will go first, what reaction will go second, mana reaction yang cepat, mana reaction yang perlahan, mana reaction yang saya boleh suppress, mana reaction yang saya boleh increase, so on and so forth. So I actually do this for my PhD study. So I hope you understand the complexity of this. So later bila kamu design, bila kamu nak kira rate law ni, itu masalah dia bila kamu perasan reaction kamu tu bukan berlaku dalam satu cara tapi dia ada banyak mekanisme. So that's how your confusion will get, because kenapa? Because you can really see this in terms of time. Sebab tu kamu perasan kenapa kadang-kadang tindak balas yang sama tetapi masa berlainan memberikan produk yang berlainan. Kenapa? Because let's say you have very short time, katakan kamu tindak balas kamu dalam masa yang pendek, dia hanya certain mekanisme yang sempat berlaku, mungkin yang mekanisme lain memerlukan masa yang lebih panjang. So if you prolong, you see your product might be different because there are other mechanism taking place at a longer time. So reaction ni dia ada dia punya limit dia ada boundaries dia ada dia punya different parameter. So let's say you have satu reaction tu 10 mekanisme. Mungkin 5 mekanisme pertama berlaku pada 5 saat pertama, the next 5 mekanisme dalam masa 10 minit yang berlainan. So kamu prolong reaction tu, kamu boleh tengok perubahan produk tu kenapa tak sama walaupun tindak balas yang sama, because of that. Different mechanism, different time, different boundaries. Okay, so that's the challenge of rate law sebenarnya in that situation. Okay, right? Okay, so I hope I explained it well. Right, so I come back to the lesson. Okay, now, based on the reaction order, okay, so let's say you say we have alpha. So the reaction is alpha order with respect to A and beta order with respect to B. Whenever you talk about reaction order, you must be very specific to which reactant. So katakan you say first order with respect to reactant mana? If you have one reactant, tak apa, definitely A kan? But if let's say you have two reactant and you kata reaction tu first order, it can be first order with respect to A, or it can be first order with respect to B. Katakan second order, kamu kata reaction tu second order. Second order lagi susah sebab second order can be second order with respect to A, can be second order with respect to B, or can be first order with respect to A and first order with respect to B. Total order masih second order. So you have to really explain order based on which reactant. Even in my exam or test question, I will specify the reaction is first order with respect to A, Ca power 1. The reaction is second order with respect to B, Cb power 2. So you have to be very specific. Okay. Then overall order. So overall order is kamu jumlahkan saja order A dan order B. So it become alpha plus beta, you get the overall order. Okay, so let's say kalian katakan the reaction is first order with respect to A and first order with respect to B. Overall order 1 plus 1, 2. Okay, so let's say the reaction is first order with respect to A, second order with respect to B. So overall order 3. Rate law dia minus RA equals to K CA power of 1. Tak tulis pun tak apa. CB power of 2. Okay, selesai. Okay, next question will be, like I told you, right? Kalau katakanlah saya kata reaction order ni kompleks nak tahu, then how do we know? Okay, how do we know the reaction order? Okay, so to know the reaction order, kita bahagi dua. Okay, we call it as either elementary or non-elementary rate law. Again, I repeat. Nak tahu rate law, nak tahu dia punya reaction order, tertib tindak balas, dia depends reaction tu elementary ke non-elementary. Yang tadi saya cakap kompleks tu, okay, now you can understand it better. If it's elementary rate law, okay, but if you read from literature or in the exam question, I state the reaction follows elementary rate law, or I say the elementary rate law reaction, so on and so forth, meaning dia punya reaction order follows the stoichiometric coefficient in the equation. Maknanya tertib tindak balas tu betul-betul mengikut perkadaran stoichiometrik. Okay, contohnya katakan kes kamu, reaction kamu 1A reacting with 1B, produce 1C, 1D. So the reaction order is first order with respect to A and first order with respect to B. Kamu ikut je stoichiometric coefficient tu. So become minus RA equals to K. K tu mesti ada, apa-apa situation pun K mesti ada. K equals to CA CB. Okay, meaning first order with respect to A, first order with respect to B. Kalau sesuatu tak tulis pun tak apa. So let's say we give a real chemical reaction. Let's say 2NO, okay, react with oxygen gas O2 to produce 2NO2, nitrous dioxide. Okay. So dia kata this is elementary rate law. Stated reaction ni obeys elementary rate law. Therefore, dia punya rate law, dia punya order reaction become second order with respect to NO and first order with respect to oxygen gas. Okay, kamu ikut sahaja reaction order tu ikut stoichiometric coefficient. So it become minus RA. RA kamu adalah NO. So kita tulis sebagai minus RNO. Rate of disappearance of your NO equals to K. Concentration of your NO power of 2. Concentration of your oxygen gas power of 1. So this is for elementary rate law. However, kalau katakan reaction tu adalah non-elementary rate law. Part ni yang selalu student confused. Kalau dalam literature ataupun dalam soalan kata follows elementary rate law, kamu tengok stoichiometric coefficient. Tetapi, macam tadi saya kata kamu kan, ada reaction yang banyak mekanism kan, okay, dan dia punya rate law tu dah tak mengikut stoichiometric coefficient. This is what we call as non-elementary rate law, meaning rate law dia dah tak ikut stoichiometric coefficient. Sebab, like just now I explained, certain reaction ada banyak mekanism and rate law ni berdasarkan mekanism ataupun tindak balas yang bukan yang dalam persamaan kimia tu. Okay, maksudnya, in that case, is stated in the test or in the exam or stated in the literature. It is non-elementary rate law. Reaction order tu kamu dah tak boleh tengok persamaan tindak balas. That information has to be provided to you kalau dalam exam, literature or in a real situation, kamu kena buat macam apa yang saya buat untuk PhD saya kena buat eksperimen, I do the reaction, I calculated the rate law by, not calculated, I do modeling based on the reaction to know my reaction order. Itu adalah real practical lah dalam real application. That's what people do. That's what engineer do. That's what, this is actually the work of engineer. They run the experiment, they run the reaction, they do the modeling to know your reaction order. Tapi itu adalah practical lah. For your case as a student, that information is to be provided to you. Means I will inform you, okay, for this reaction, it is first order with respect to A. Ataupun I will tell you information dalam soalan, the reaction is second order with respect to B, so on and so forth. Means without the information, you would not be able to know the rate law. Okay, so that's all for today. You still have about 3 minutes. Now I will end the class for today. So I will see you tomorrow at 9 o'clock. Again, dalam kalender saya letak pukul 9. So for you guys, please be aware about kalau apa-apa, if I do any class cancellation, which is very rarely, I rarely cancel class. You can ask my seniors. Unless I have special emergency thing that I cannot avoid, I will put on your Teams and I will change, I will either cancel the calendar or I will reschedule. Macam semalam saya reschedule kepada hari Rabu ni. So dalam kalender saya dah explain kenapa saya reschedule kepada pukul 9. So please always check your Teams. Make sure you're connected to your phone. You check on your Teams if there are any changes. But for my case, very rarely lah even if I cancel, so I will reschedule. Tapi saya akan reschedule within time yang dibenarkan. I will not take your extra time because I think it's not fair. Saya tak boleh buat, saya tak boleh ambil masa luar kamu. Macam besok memang masa kita, memang our lab time. Just like we don't do lab, I use it to do tutorial. So the tutorial tomorrow starts at 9 o'clock. Although dalam timetable 8.30, but 8.30 I know it's too early for you guys. You have extra 30 minutes to sleep. Just come at 9 o'clock. Make sure you have pen and paper with you. We can do the tutorial question together. Okay. So that's all for today. I will see you tomorrow at 9 o'clock.